Thank you, Chad. I'll go ahead and change to myself here. And please let me know when you're able to see my screen. Excellent. So very quickly, I'm going to place myself right over here for the moment. So that way I'm not just a disembodied voice. I want to welcome everyone to this morning's presentation for Autodesk Vehicle Tracking 2014. So we're going to take a moment to learn about it, basically a technology review. And I'll slide myself right out of the screen here. Go ahead and begin. First, a little bit of perspective. A famous person once said, discontent is the first necessity of progress. And that person was Thomas Alva Edison. Clearly, he found lots of things to be discontent about and felt that needed improving. So just as a frame of reference, we need to be at a point where we have to be willing to want to improve and find those points of discontent. Briefly about myself, been with Autodesk about 7 years now. Prior to that, I was at a reseller here in Southern California where I'm based for approximately 9 years, taught quite a number of the different Autodesk products over that time, provided technical support, etc. Been an Autodesk University instructor. And then prior to that, I spent 14 years working at a couple of different civil engineering companies here in Southern Cal. Started off in traffic engineering, but learned AutoCAD back in '87 and have always had the hat of being the CAD manager. So being responsible for my coworkers, not only in our management of the software, but in their understanding of the use of our software and how to make best advantage of it, making sure that everyone's well trained with the product. So for today, the goal will be not only to provide exposure to the Autodesk Vehicle Tracking product, but to review in detail a subset of some of the capabilities, have an understanding of the business benefit of Autodesk Vehicle Tracking, and then hopefully be able to address the majority of the questions that may exist. So with that, I'm going to go ahead and begin. As far as an overview goes, we're going to focus on 3 key areas of the product. First being evaluating vehicle movement. So we understand that vehicle tracking does have to do with how vehicles track on the road and or on site or in campuses as they maneuver within those environments. We'll also be looking at some of the optimizing of road or campus geometrics, what's possible here with vehicle tracking, and have a little bit of an understanding of what the real-time analysis that we can get from the product. So I'll do so via a brief demonstration. I'll have a summary at the end. Definitely, as Chad mentioned, we'll have a portion for questions and answers as well. So with that, I'm going to go ahead and jump right into the product. And let's see here. Here we are inside of Autodesk Civil 3D. I have a number of drawings already open across the top. And I'll start perhaps here with this one. So I'm now going to select vehicle tracking on the ribbon of AutoCAD Civil 3D 2014. And we'll notice, or I want to mention a couple of things first. I am inside of Civil 3D 2014, but vehicle tracking installs itself on top of any AutoCAD-based environment. So whether that be what some people refer to as vanilla AutoCAD, Map 3D, Civil 3D, Utility Design, any of these other products, absolutely vehicle tracking can install itself on top of that. I feel that it's best suited to be installed on top of Civil 3D specifically because it does have the capabilities, as we'll see a little bit later, to actually interact with Civil 3D intelligent objects. So we'll see that over the course of time. But here I'm in a very simple AutoCAD drawing, and let's go ahead and then begin this process. So we'll take a look at three different capabilities here, dealing with swept paths, parking, and junctions. Starting on the swept path side of the ribbon, I'm going to begin the process and just point out that there's quite a collection or a library of vehicles that already pre-exist in the product. As a matter of fact, the total number of vehicles exceeds 1,000. So down a little bit lower here, we see that there are U.S. Oh, someone has placed us on hold. Okay, so let's do the following, see if I can do this. Okay, how about now? That's fine. So further down here, we see U.S. design vehicles. I'm going to go ahead and expand that, but wanted to point out, even at the very top, we see aircraft and support vehicles, commercial aircraft, military aircraft, support vehicles related to those, baggage trains and buses and fuel trucks, etc., are all part of that collection at the top. Further down, we see in the U.S. collection there are some certain states that have vehicles that are specifically designed for them, California, Florida, Illinois, etc. I'm going to look to the AASHTO standards, or the statewide vehicle standards, and down here the 2011 AASHTO standard, and let's choose, let's see this, first let's start off with a bus. I'm going to grab that particular bus, and let me, for the moment, I suppose, make that, let me clear any defaults. Okay, so I've selected this bus. Now, one of the things that's possible also is I'm going to choose to look at the diagram. So here we're seeing the diagram of the particular bus that I'm speaking of. We can see it's just under 36 feet long. Some of the facts about it: width 8 feet, overall body height, minimum track width, or excuse me, the track width and the minimum clearance from the ground, etc. All can be determined here from the catalog. Now, if necessary, it's absolutely possible to make copies of certain of the vehicles, make modifications to these vehicles, or to create one's own vehicles. So we'll have that understanding now. So I'm going to go ahead and hit OK. So let's come back and begin a process called Auto Drive. So with Auto Drive, I have that vehicle selected. We'll choose Proceed. It's going to ask me if I wish to make that the default vehicle. And I can certainly ask it, don't ask me again, but I'm going to say no to that. And there are some settings very quickly about the scale, about any surfaces that, if the surfaces exist, I can drive on the actual surfaces. And as I mentioned, this is just an AutoCAD drawing, so there's no surfaces. And then there are other things here that I can control. So we're now using the product. I'm going to come down here to this bottom end of the drawing and place the vehicle and then give it a target direction. Now after that, we have some controls over the vehicle. I'm just going to say it, do this auto driving and just basically tell it to proceed. And then you will see that as I maneuver my crosshairs, that we will get a path, an outer green envelope of the path of the vehicle. And we'll talk about that in just a moment again. So I'm going to go ahead and pick as I maneuver up towards this intersection. And then there's a left turn lane, or a dual left turn lane that I'm going to pull into. And as I approach the intersection, I'm going to begin my turn. And then I wish to point out one other thing here. Right about here, we may also notice that there is not only a green envelope, but a red envelope. This has to do with the green envelope being the full vehicle itself, the envelope of the body of the vehicle. The red envelope would be the envelope of the wheel track. So wanted to point that out here as we're working. Okay, so I'm going to proceed up through this intersection, approach the roundabout, and here at the roundabout I want to take some I'm picking points that are closer together to have a little bit more control over the vehicle itself, and then basically drive out of the scene and at that end and hit a return, basically to end the process, correct? So first off, again, in reviewing the process, we'll see that we have then this very intelligent object. As I select it, it is the entire auto turn path, swept path. As I select it additionally, and we look at it more closely, we'll see that there's a couple of different types of grips that are available. There are these X's, which if I hover over one, it says adjust the target point. So I can grab that point, and then you can see I can, after the fact, make adjustments to that. If I were to, in fact, place that point somewhere where I could not reach from the previous point to that point with the steering of that particular vehicle, the envelopes will go back and stop at the previous point and saying I can't get from that point to the next. So coming back and editing that, I can just very simply grab, edit, and replace that into a path that that is appropriate. Now, if I find that coming back down here to this particular intersection, I based on the frequency that I allowed here, this turn was decent enough. But if I find that I need to, I could come here with these little X's, and it says to insert a target point. So I can just select that and then add another target point intermediate to this process, right? And then so I have a couple of different X's here and then maneuver them as I see fit. So as far as coming back after the fact and editing the swept path, a rather simple process to do. So here you can see that based on some of the changes I made, it did stop there. I've come back and made the adjustment so I have a continuous path all the way from start to finish. Now this vehicle path will work through this roundabout, of course, assuming, as you can tell here very clearly, that that hatched area of tile be considered some sort of drivable surface. And as long as that's the case, then this bus would be able to make that. If that were not the case, of course, I would want to probably steer or oversteer into the oncoming traffic a bit to make that happen. So the first capability then would be to do this auto drive capability. I'm going to go ahead and go into the second drawing. We'll explore a little bit more about how this functionality works. Maybe I don't wish to specify every particular point in the path. Here what we're going to do is we're going to bring a delivery vehicle onto this property here. Let's see, I want to make sure that your screens and let's see, I don't know that. Let me try to okay. I'm back. I'm going to address any questions that I see at the moment. I'm assuming everyone has dialed in, and someone mentioned their screen has froze, but I'm assuming that it has caught up to now. And Chad, I'm going to leave this back on where I would hear anybody. So if I do get too far ahead of what you're seeing at your end, go ahead and let me know, and we'll try to. I'll try to moderate my my narration to what you may be seeing on your screens. I just don't want to get too far ahead in case some of the machines have a different internet connection speed and perhaps be a little bit further behind. Okay, so as I was saying here, the intent would be to drive on site here, make this turn into this parking area, perhaps come this way, then back into this particular delivery stall right there where we see the arrow. So I'm going to initiate the auto drive once again because I don't have a vehicle as a default. It's going to ask me what type of vehicle do I wish, and here I'm going to choose a delivery vehicle, single unit, tractor trailer to show. I guess we can go ahead and select that, pointing out just the particulars of that unit, 30 feet long, etc. Okay, so selecting that vehicle, I'm now ready to proceed. So I'm going to place it then in the drawing, specify my location, and I'm going to begin this auto drive capability. So I'm going to come to about here, and I'm going to use, I've done 2 picks now, a third pick here, pick on the drawing. Now what I just selected is pick alignment, so I can actually pick entities within the drawing. Here's just basically a polyline, which is the lane line there, and then I'm going to pick inside of this. Basically it tells me I wish to now end up at a point that's parallel to that road, and you can see I can maneuver and specify then where specifically related to that road do I wish to end up. So I'll pick there. I'm going to choose to pick another alignment. This time I'll pick this curb line over here on this side, and I'm going to pull in parallel to that, right about there. And then lastly, one more time, picking the side of that parking stall and back up into there. And with just a very few clicks, I was able to then begin the process of laying this out. Now, I wish to point out also that not only is this able to track the vehicle in the forward direction, also tracks the vehicle in reverse. So here we can see that there is a darker red and a darker green envelope of the vehicle as it's proceeding in reverse. Now, clearly at this point, there is a challenge with meeting and not going over some of the curbs, so I may wish then to add another point, maybe oversteer or change some of these locations as appropriate to make sure that it ultimately is able to maneuver into that process, right? Okay, so likewise over here, I want to point this out. As I enter the turn, I'm proceeding over the top of this curb. I want to point out these little arrow grips here. It's a side overturn. So both at the entrance of the curve and at the exit of the curve. So I can select that particular grip, and then you can see me adjust the particulars of that turn. So maybe the vehicle would not be able to turn into this particular entrance without steering into the oncoming traffic, certainly at slow speeds. Very common for us to see something along those lines in tight quarters, correct? So able to come back in after the fact and make adjustments to all of these things relatively quickly and relatively easily. Right. Okay. Now, one other thing that's possible is I can select that, again, it's a very intelligent object over the course of its entire path, and begin to animate it. So here with the animation capabilities, I'm going to start the animation. I'm going to turn this into 3D, create a flyby camera as it's referred to by the software, and just point out here that I have some basic controls over the placement of my point of view. I can move myself forward relative to the vehicle, or from the left or to the right of the vehicle, also changing my view height here, get higher or get lower in relationship to that vehicle. I'm going to go ahead and tell it to drive or play, and that vehicle will begin to move. Let's make this a little bit faster just for the sake of time. And then maybe as I move around the side of this vehicle, we can see that it will then be approaching the entrance drive, and we'll actually see the tires turning as they were required for that particular vehicle to make that particular movement. So coming over here, we'll see it pull to the right, to the left, and then stop, and then begin its reverse movement to get back into that particular parking stall. So we have the ability then to fully describe to someone this process, and also would be helpful to understand if there are some overhead clearance issues that would need to be addressed. This absolutely could help us tell that story, basically, give us confidence about whether something would be possible or not. And there we were able to get through to completion. So I'll go ahead and close that process. A couple of other things regarding that very intelligent object. One is I'm going to go ahead and drop in here the profile of that vehicle. So as, again, similar to what we saw in the preview pane, we can understand both the profile of the vehicle and all of the very important values as they relate to that vehicle. In this case, I can see the wheel-to-wheel center is 20 feet, from the nose to the first axle, 4 feet, etc. All of those values can be seen here. Additionally, I'll grab that very intelligent object, the swept path, and I'm going to place a graph on the screen. Now this graph, which is ultimately linked back to that particular object, helps me understand the actual steering wheel position over the course of that particular path. So I began with a right turn, straightened out here. I'm in that minor street. I did a left turn, and then we went into reverse, etc., and I made all of those particular steering changes. And it does tell us then how far, what percentage of the steering, total steering, ultimately, where are we? And if we were to do design check on that, we could see that it did provide me some information that I'm in severe steering conditions, right, where the steering wheel was exceeding the 95%. Maybe that was necessary for me to go to full lock on the turning radius of the vehicle in order to get to where I need to. So we understand that at full lock, we're probably proceeding at very, very slow speeds. Okay, to continue. So that pretty much addresses the swept path for the moment. Let's go on to the another portion of this drawing right over here. I'll come back and we'll talk about swept path again in just a moment, but we're going to proceed on to the parking stall creation, the on-site or on-campus assistance that we can get as far as creating the parking stalls for ourselves. So with that, I'm going to choose to create a brand new row of parking stalls. And there are some settings that we can control about the drive path. It's currently 2 directions. Vehicles the parking stalls are going to be 90 degrees, etc. And I'll turn on my O-snap here, and I'm going to snap to the outer perimeter of this parking design. And noticing that there are, in fact, curves. There's a compound curve in the site of the stalls, of the lot itself. So I'm going to go ahead and pick the next endpoint here. Let's pick that endpoint there, and then this endpoint here, and this endpoint here, that endpoint there. Going to the endpoints of these curves, that's one curve, and then we have the compound curvature down here to the end of the other one. And I'm going to go ahead and hit a return. Now, one of the things that's very helpful here is I have these white glyphs on the screen, and they control where will it ultimately lay out the stalls. At the moment, it could be just to the inside. That's what this basically represents. I could put stalls to the outside, which would make no sense. I could put stalls on both sides of the path that I just specified. So here I'm going to pick just to the inside, and we'll see the outside stalls will all disappear, and that begins to make a little bit more sense as to what we were doing. Additionally, in this area where we saw the arcs as a part of the outline, I'm going to go ahead and grab this glyph here, the grip, and then pull that out to there. So we see that now it will follow that outside curvature. But not only that, as I'm doing it, you'll see that the stalls do in fact dynamically update to give me that understanding of where will they ultimately reside. Now, just a couple of quick things about what we're seeing on the screen. I'll go ahead and accept that. One is that I see that in this area in front of the stalls, it's expected that we have 2-directional traffic. If I select the entire object and grab that particular grip, I can change it from one direction to the other direction or to 2-direction. And we see this blue guideline here. That changes based on the direction of the cars that are coming in, so that we have that understanding. How much clearance would typically be necessary in order to pull into any of these stalls. Now, the next thing I'm going to do is technically not going to be perfectly accurate, but it'll help us make the decisions that we may need. So maybe someone would then come back and say, maybe I wish to create a parallel row of parking to those that already exist. So as I choose the parallel option, and ask me which road am I going to be parallel to, I'll pick these outer stalls, and then we can see that I can then place additional stalls here. Now, it is allowing me some freedom as far as the placement, but once I get to a certain point, it doesn't allow me to go any closer to those other stalls because it knows that it requires a certain clearance there in order to pull into those stalls and then potentially into these new stalls. So I cannot get any closer to make that driving lane any narrower than the appropriate settings. So I'm going to go ahead and pick that, place stalls on both sides, and obviously this would not work because I leave then this hollow area here, and clearly there's some stalls that overlap here in this really tight curve. Really odd. That would not be typical. So I'm going to go ahead and delete that just with the simple AutoCAD delete command. I'm going to create a new row of parking stalls, but with the understanding that blue line is our guide for the moment. So I'm going to go ahead and place this in there, hit a return. place the stalls on both sides, and then point out that we have control over the end situation. You can see I can control here the actual angle of the last last stall there, the striping. I'll go ahead now at this point and do parallel rows, and you can see that same thing, that same applies. I can only get so close to that, place that down in there, control the both directions, maybe bring this back here a touch. And here I'll do both sides simultaneously, right about there. And then one last time, set of parallel stalls right about there, both sides. And you can see how quickly and easily I was able to lay out all of these stalls very quickly. And those of us that have created parking stalls over the course of time with what I'll refer to as generic AutoCAD, clearly that becomes a little bit of a tedious operation, particularly as we start to make sure that the stalls on the narrow side of concave situations or the front side of perhaps of convex situations are in fact properly spaced and properly positioned so that we get all of the stalls appropriately. Now, another thing that's possible is I'm going to come back in here and edit a parking bay. I'm going to specify this first stall here. I wish to make that a disabled stall, and then I'm going to copy that into other stalls. So coming down here, we see that we've made that first one a handicap stall, and then just copy that into other ones. And along that entire length, we see the entire collection of stalls will adjust to accommodate these new stalls that are handicap stalls. Once I'm through, I'll go ahead and end that process, and we see that I very quickly assigned or created handicap parking stalls up near the front entrance, perhaps, to this building. Now, very importantly, once we do all of this, of course, we need to understand how many stalls did we just create? What does that, in fact, satisfy the ultimate needs for this building? So we have here the parking report, and then within this report, we can see the number of regular stalls or traditional stalls here, 145. We see that we're 94.7%, almost 95% of the stalls are in fact regular. And then I've made disabled stalls 8, and that's 5% of the overall number, and maybe that would properly satisfy the requirement, you know, the regulatory requirement about handicap stalls on any given lot, and for a total of 153 stalls, right? So we have that. Not only are we able to very quickly lay out stalls and create stalls, we have then that level of understanding about whether or not we're going to satisfy the regulatory requirements on these stalls. A little bit of analytics, basically. I'm going to pause now and ask for any questions. I do have more of this of our presentation, but I am going to pause now, and maybe we'll take two question and answer sessions, one at this point. Anything up to the moment? I believe everyone is unmuted right now. Feel free to just speak up, or can you put the report in the drawing? Let's see, I haven't tried that. Customize, export. We have some customization. Will show selected columns. Let's see if we can do this. Turn some of these on. And then export this out. At the moment, we see that we have a comma delimited file. And of course, a comma delimited file can be brought back into just generic AutoCAD. Okay, is there an add in that is required for others to view the parking lot object? That's a very good question. I don't know the answer to that. Let me, in my notes here, pardon me for just 1 second. I have a document of notes, and I can certainly address that. Let's see, question right here. Add in required to view. And my first guess, and now that I thought about it clearly, and add into view required to view parking lot object, parking lot. Okay, now I'm going to give you the official answer. The answer is going to be no. There's no additional add-in that's required. It'll probably be visible as a proxy graphics at their end, but certainly would require a couple of things. Sometimes we as a former person that did technical support, etc., we often got questions, oh, someone created something that's very intelligent, I don't see it on my drawing. And it's a two-step process. Typical in AutoCAD, on the creator side, they have to have proxy graphics turned on, proxy graphics. I have to have it set to 1 so that in fact embeds proxy graphics into my drawing. And then at the other side, I'm going to go into options here very quickly. On the display side, they need to be have the proxy graphics as a display, open and save. They have to show proxy graphics at their end, show proxy graphics, pardon me, at their end in order to make that all visible. But sorry about that. It took me a moment to fully get the appropriate answer for that. If truck routing works in 3D, can I see vertical conflicts and clearance like a railway crossing? In fact, there are some. There is here a setting for vertical clearances to have some sort of understanding about some of this. But as far as physical objects, most of that would need to likely be a visual check about those objects. Let me see here. Clear vertical clearance. And now that here's another, let's go ahead and go into my next drawing, as a matter of fact, because this is important when we start talking about clearance of vehicles. Now in this drawing, not only do we have a path of a vehicle, of a turning vehicle, but we also have a Civil 3D corridor. So as I touch here, we see that we have a Civil 3D corridor. It's called Corridor 1. Now this particular vehicle, I'm going to select that and drop in the profile of this vehicle right about there. This is what's referred to as a lowboy, incredibly long, right? It has double articulation here. We have a point of the first articulation point here. We have a second articulation point. So basically it's a 3-segmented vehicle, the last segment, of course, being very, very long. We can see the wheelbases and so forth. But one number that I wish to point out very clearly is the minimum body ground clearance is only 0.4 feet or approximately 5 inches or so. And that would be right about here, very low clearance to that lowboy to the ground. So in 2D, we can see that this vehicle clearly was able to make, once this road was widened, clearly able to make the turn, although well into the oncoming traffic. But now, instead of not only just 2D, we wish to verify, because of the overall length of this vehicle and a road being a typical crowning situation, we wish to verify what is this going to look like over the entire path. So I'm going to first grab that, again, very intelligent object, and I'm going to place on the drawing outlines of that vehicle. So over the course of its path, I'm going to place this outline. So now you can see that I'm in essence dragging a copy of that vehicle along. So right up to about here, I'll place a vehicle there. I apologize for the color blue there, but it is then placing that vehicle going through this turn. I'll bring it up to approximately right about here, and then drop this down right about, let's see, right about here. And then I want to point out what's happening here at this particular location for this rather sizable and very out of the ordinary vehicle. So here, the front end of the vehicle, the first set of articulation points, are already on the through street, excuse me, in the vertical street, and would be more to the right from, if we imagine a typical crowned road, the outside wheels then are more basically lower right on the street than would be the inside wheels. The rear wheels also, being on a typical crown street, are well to the left of the crown in the lower portion of the street as well, over by the curbed area. So we then have to be a little bit concerned about the fact that we have our wheels on lower portions of the street, but on a typical crown street up near the crown, do we have enough clearance on that vehicle in order to make that clear? So with that selected, I'll go ahead and ask for what's referred to as a ground conflict report. And when I ask for that, it's basically telling me what it's about to do. It's going to then compare itself against the profile of the road, the sections of the road itself, and then give us this area where, in fact, the lowboy based on its characteristics, would in fact interact with the ground. And I have values here that indicate how much of a problem do we have as far as those particular the clearance of that vehicle over the crown of this road once the wheels begin to straddle the crown. So now we start talking about here, in this case, of vertical ground clearance for that particular vehicle. And I think that's what the question was related to. So I'm going to go back into the fourth drawing now. We'll talk briefly about junctions, and then we'll come back and address all of the questions. So when it comes to junctions, it's possible, we understand with Civil 3D, to create something that is a 2D roundabout. This is able to create 2D roundabouts in a slightly different process, and for some people, they embrace this one a little more. Some people, I'm going to assume, embrace the Civil 3D version because they're comfortable with that. But let's talk about this and then ultimately what's possible here that's not possible in Civil 3D. So with the roundabouts, I'm going to create a new roundabout. There are quite a number of settings here, and again, if I needed to, I can certainly make that part of a surface, etc. So I'll go ahead and place OK. It's going to create a roundabout called Junction 1, and I am now controlling the center point of that junction. Now, I don't have to necessarily place it right at the intersection here, and I'm going to place it just offset just a little bit, and we can come back in after the fact if necessary. So at this point, I look down to the command line. It says select a line defining the access road center line. So here there is an alignment, so I'll pick that. Interesting, what happened there? Do I have my O-snaps on? Off. Let me start that process again. Sorry, it must have snapped to another point. So let's start with a new roundabout, junction number 1. Drop it in. It's asking me for the access road, so I'll just touch this alignment over here, and then it's going to name that particular portion of the roundabout as leg number 1, and we'll go ahead and hit OK. Now we can see it's already begun to draw some of the preliminary geometry for that. It's asking me at the command line if I wish to have another entrance, and I'll use this entrance here, leg number 2, and I'll proceed around. So now I have an L-shaped roundabout. I can come over here, leg number 3. Of course, we now have a T-shaped roundabout. And then lastly, I'll pick leg number 4, and we now have a full 4-segmented roundabout. And I could continue if necessary. Absolutely, I can have more than just the 4 legs. So once that's done, I'll hit a return, and it will then complete the process about the roundabout. And I'm going to zoom in here and just point out a couple of things. First off, it does give me some reports about the speeds going through any of the radial, the curves that are on there, what's the expected design speeds. Here we can see that there is also placing some signage, a yield sign based on some of the limiting geometry. If I grab that particular object again, we can see that it is intelligent just like all of the other, the swept object path was and the parking base. And I have various grips that I can come back in here and make modifications to. So I can change the radius, let's say here, but let's say I were to really significantly want to modify that. You may be able to see in cyan that it says entry near side radius too small. So it is giving me design feedback, or now the entry near side radius too large. So it is giving me feedback if I do decide that I was going to try to do something that's from a design perspective not appropriate. So here, as I pull this out, I get quite a number of different warnings that I'm basically busting the roundabout if I were to do that. Additionally, so not only can I do grip edits to this, it's also possible to come back and do some edit the roundabout in another fashion. This would be to do so in this particular palette. So we're seeing the corridor, and as I grab on different portions of this, the rondelle portion of it, I can see the center island, I can see some of the properties here that were used to draw that, and I'm getting similar feedback that I would expect of, say, something like Civil 3D, that as I pick in any one of these fields, it is telling me which value here in the preview would I actually physically be modifying. So if I come down to leg number 1, the approach or the entry, right, we can see the values here again being clearly identified so that I would have that understanding. What am I changing if I do decide to change that? Secondarily, coming down, let's go ahead and close that for just a moment. If I need to after the fact, by having that item selected, I'll come back up to the ribbon and I'll basically create a new crosswalk. So as I drop in this crosswalk, you can see I have control over the placement of this crosswalk. Now before I physically drop it in, I wish to point out there is a yield sign up here near what would be considered the kind of the limit or commit line, right? And then there is a roundabout ahead sign back here before that. But as I then go ahead and place the crosswalk, we can see that based on the crosswalk and the required signage required for that, it did place a crosswalk ahead, pedestrian crosswalk ahead sign, and then moved the roundabout ahead further down so that there's appropriate distance between the signs for regulatory reasons in order to for the spacing of those signs. So again, very quick and easy to not only create this roundabout in a 2D sense, but add to the geometry, etc., and then have the signage appropriately spaced and appropriately positioned so that we can have significant confidence about the design of this. Now, lastly, I will point out that it's possible I can grab this particular roundabout that I mentioned was in 2D, and then I'll come back in and create a 3D. So one moment, let me think here. Oh, I know. I need to be in my edit command here. Coming down to the corridor, I'm going to tell it to create alignments and other things in relationship to that, create profiles, everything, and then I'll go ahead and hit apply. And at this point, it will, from that 2D geometry, go ahead and create a full 3D corridor of that roundabout. So as I grab that and perhaps place that, I want to make sure that that's all I have. I'll grab that, place that in the object viewer. And now as I get into 3D, we can see that in fact I have a 3D corridor of that particular roundabout. Right. Now, so I'm going to come back to the PowerPoint. So we were able to see just a subset of all of the capabilities, basically dealing with swept path analysis, the creation of parking stalls, and the creation of roundabouts, both in 2D and in 3D. So coming back to the PowerPoint here. Where's my PowerPoint? There we are. Oops. The demonstration. So in summary then, what Autodesk then allows would be Autodesk Vehicle Tracking, a comprehensive, I'm not going to read that. It allows us then to create designs and to analyze those designs for vehicle swept path and more. So we saw a subset of the capabilities, not only the swept path movement of the vehicle, we saw the parking lot layout tools. There were some design criteria and standard libraries of vehicles that are already in the product that help us understand whether in fact the movements are going to be possible, real-time analysis, but most importantly of all are the business benefits to us. One, it's very easy to use, very intuitive, and of course obviously very powerful. It works within a standard AutoCAD environment, so people that are AutoCAD users, traditional AutoCAD users, are well familiar with much of what's possible as far as moving, copying, rotating, using standard AutoCAD commands. And then allows us to very quickly, with significant speed, not only plan something, but ultimately design, perhaps changing our processes, and very obviously evaluate. Move that off the screen. That's trying to change my colors for presentation purposes. Very quickly evaluate various alternatives, right, for that. So with that, I'm going to go ahead and review any questions that I may not have addressed. So starting at the top once again. Screen size. I think the screen size was at the viewer side. Someone said that it looked pretty good. Someone else said that that looked great or cool. Putting the report in the drawing, we saw that there is a workload that would allow that. Now, I'm going to be very upfront about this and say I being a relatively new product, I am by far from what I would consider to be an expert. I've only had this for just a couple of weeks, as a matter of fact, and been able to accomplish quite a bit in just those few weeks because it is so intuitive and easy to learn. But let's see, if truck routing works in 3D, can we see the vertical clearances? We talked about that. Like railroad crossings, absolutely. So if there are railroad crossings built into the surface, it can absolutely check that as part of the process, which I think we understood. And if we have a network seat or a couple of network seats and 20 potential users, how is the seat returned to a user if it is done? Vehicle tracking ribbon returned to the seat. Let me see one thing here regarding the network use of this product. Pardon me for just one moment. I wish to verify how the product would install as far as a network version. Network vehicle tracking would work fine on a standalone AutoCAD, but it would once, that's a good question. I'm not certain if it immediately upon launch, if it takes up a license, or once I activate one of the commands. That's going to be a good question for me to get back to everyone on. So I'm going to put that into my notes. Okay. When does it pull a network license? When? Network license. And coming back to the questions, pardon me, the grip the center and move it to it after you're done. Oh, yes, absolutely. That's good question there, and I should have done that. Coming back to drawing number 4, if I were to go ahead and come back and grab the original underlying 2D roundabout, you can see that I'm able to grab it, and it will, again, redesign everything. So if I were to come back and place that at, and I'll just eyeball the accuracy for that for the moment, and if my corridor is set to rebuild, which by default this one is, everything gets rebuilt right on the fly. So thank you for asking that question, something I probably should have done. So after the fact, as far as making adjustments, not a problem. Things will dynamically both redesign in 2D and ultimately rebuild in 3D in the corridor. Thank you. Do the roundabouts and vertical clearance exhibits show only with corridors, not surfaces such as a site plan? No, and it is possible to interact with just a surface versus a full-on corridor. So if I had a corridor, I would need to create the surface to that corridor for that ground clearance to take effect. And so, and having a surface would be adequate. And I think that addresses all the questions at my end. Any other questions? If not, then Chad, what I'm going to go ahead and do is I'm going to come back here. I wish to thank everyone for your participation this morning, and wish you a very great rest of your day. And with that, I'll turn that back over to you, Chad.